Hello, this is Christian Selassie with Kiefer Armand, and this is a demonstration of our database. We wanted to note that before we begin, we believe the full potential for a database would be best shown in a centralized network server instead of a local SQL server. However, this is outside of the scope of our current skill set. Getting right into it, we initialize the database first thing, then we create all the different tables that are used for our composite and multi-valued attributes. We need to do this as the entities they are linked to, person, officer, ticket, and court case, borrow their primary keys. It is important to note that while these tables may look like entities in MySQL, they're simply broken down attributes. This becomes more apparent when looking at the ER diagram. These tables are fully functional, however with some, we had some difficulties creating the primary keys. Both address and location use prime attributes in tandem rather than a single unique attribute. You will also notice that some attributes use high count varchar values, up to 100 even. These domains are in place because we expect these attributes to have a higher degree of variance. Throughout the code, you will see similarly sized attribute domains, most of which function in the same way. After the composite and multi-valued attributes come the entities. There are four main entities that were listed before of person, officer, ticket, and court case, and some pseudo-entities that we will discuss later. The entities are linked via the relationship tables that are created below. The gives table links officer and ticket. Ticket number is set as unique because each ticket can only be given once, while an officer can give out multiple different tickets. The receive table links person and ticket. Once again, we see that ticket number is set to unique. This is because while a person can receive multiple tickets, each ticket can only ever be received by a single person. The becomes table links court case and ticket. Here we see a break from the norm. Case number is set to unique while ticket number is not. This is because multiple different tickets can become a single court case. Lastly, we have our outlier table, holds, which links violation and ticket. Violation is a pseudo-entity that we mentioned earlier. In reality, violation is a multi-valued attribute of ticket. However, since violation is a set list, we found that it functioned more appropriately as an entity. Neither ticket number nor violation number is set to unique, since a violation can be used on multiple different tickets and a ticket can have multiple violations. As an example, we will show you the inputs for vehicle and ticket tables in order to demonstrate the parent-child relationship as well as the error constraints we have put into place. We have a couple of triggers in order to ensure that different, more sensitive input values are within range, such as our first trigger, which ensures that badge number is a minimum of 5 numbers. Our last two triggers revolve around ensuring different relationships remain coherent. So for example, if the status of a court case is still in court, then the resolution in public record will always be null because it hasn't been solved yet. The same is true of resolution. Columns in a tuple that are changed and are shared across multiple tables are thus changed at the same time. It is important to note that the tuple needs to be updated at the parent in order to change anywhere at all. So in order to change a ticket's license plate, you need to change the license plate number in the vehicle table for that tuple. For views, we have 3 primary ones. We have one for displaying data appropriate for a police department to see, one for the public, one for the person who received the ticket, and finally one for the court system. Some of these have more restrictions on the data than others. To be specific, police and court systems have access to all the data. The public does not have access to more private columns of data, such as social security numbers, and the receiver only has access to their tuple of data. The views currently do not have any data inside them due to a lack of coherent and usable data in the tables overall. To finish off this demonstration, we want to mention who did what in this SQL database. So, I personally constructed relationship tables, coded the views, created dummy data, and am the luscious voice you are hearing right now. Kiefer created and refined the entities, including the multi-valued and composite tables. He also coded all the different triggers and revised as well as sorted multiple components of the database, such as the insertions, entities, and just about everything. And is also the one editing and recording all this right now.